I'm going to teach property by property first. Okay, so the first property that you need to know is this chords of a circle. So over here, we know that angle bisector of a chord. So when they draw a perpendicular line from the center down here, okay, perpendicular, you will know that this AB will actually be cut into like half. So that's why AM is equals to BM. Okay. Next is this is simply telling you that this is perpendicular. Next is what when you have equal chord. Okay, this is called a chord. As long as it's not a diameter. Okay, see, this is passed through a center. As long as this is a diameter, anything which is not a diameter, like this one, all these okay, all these they are all called a chord. So when you have equal chord, means CD and AB is equal. Okay, and this will be equal. Okay, that's why they say it's equal distance from the center. Okay, this is the first property. So let's just do some questions based on this property. Okay. This property is pretty easy, this property. Okay. Let's just do a, okay, I'm going to skip. Okay, I'll jump to question 3. Okay, look at this question. They say find the perpendicular distance from the center O to the chord. So we know that we will draw a line from the center to here. This is perpendicular, and we know this and this is equal. So what can you say? You say like can label this point as maybe say M. So what you do is you will say, oh, okay, so OM is perpendicular to OP, QP. And of course, this one you can actually put there as this one. Okay, perpendicular from center bisect the chords. Okay. So with this, you will say that, oh, so QM is actually equals to 30 divided by 2, which is 15 cm. Okay, for the first few questions is very basic. I just want to touch on each property, some question. Then after that, the last 2 questions will be combination, which is the typical kind of question that you see during tests. So this is 15 cm, where is 15? And this is a right angle triangle. Whenever you see right angle triangle, you link to 2 concepts. It's either Pythagoras theorem or Trigo-Torcaso. But this one got no angle involved, so we know that it's just Pythagoras theorem. So from the Pythagoras theorem equation, 15 square plus this OM square is equals to 17 square. So we know that OM is simply just 17 square minus 15 square, and then you square root, and then you get the answer. Okay, that's for question 3. And the answer is just 8 cm. And we're done. Okay, this one very simple property, so I just do one question. This property, angles in a circle. This is a very commonly come out kind of property that they always like to use. Okay, angle at the center is equals to 2 times the angle at the circumference. This one, the bracket, is the reason that you're supposed to write the side. So sometimes people solve, but they never write the reason. So you never write the reason, you will eventually will be minus 1 or 2 marks because you never put the reason. Over here, you need to know that when this is x, this is actually 2x, double. So it's like how you draw, how you usually is have a common base. You see, I'm going to join A and B. See, AOB and ACB, they both have A and B. Common base, I call it common baseline. So it means that one is touch the center of the circle, one is touch the circumference of the circle. So we know that it's double. Okay. Next. This one. When AB is the diameter, okay, we know that this is 90 degrees. Okay, wait. Okay, so this one is 90 degrees. So the property is called angle in a semicircle. Okay, so every time they tell you got the diameter, first thing you need is you spot the 90 degrees. Next is, this is also another common one, which is the angle in the same segment. Okay, both angles, there's one property that is not shown here, which is commonly, is actually linked to this property. But I need to highlight over here. So you can draw on your paper whatsoever. See how I draw. This is, I'm going to draw this. Okay, and then join this and this. Okay, I'm going to say O, A, B, and then C. And then I'm going to join the line here. So over here, if this is angle X, okay, you see they share a common AB, right? Common mistake is student will say, oh, okay, they ask you to find, they say that this is 2x of here, which is wrong, which is wrong. So you take note that when you form a diamond shape, this are called a diamond. You see, this one is not a diamond, right? Okay, this is called a diamond shape. When you form a diamond, the 2x is another place. It's not inside. It will be outside here, 2x. So please remember that when you form a diamond, the 2x is the outside one. It's not the inside. Okay? Okay. So this is the so-called tricky one, which a lot of students always don't know. Okay, now let's do some question on this type of property. Okay, over here, let's see. Use another color. Of course, it's not very straightforward. Okay, let's take a look at this one. B. Very easy. Okay, AB, common base. AOB, this is touch the center. This one touch the circumference. So if this is 80, we know that X is just 80 divided by 2. And we put 40 degrees. Okay, and then the property, you see, where usually students don't know where to put the property. It's very easy. You put 80 divided by 2. Why do you do that? So you have to justify with a statement and say that, oh, I divide by 2 is because of this property. Angle at the center is equals to 2 angle at the circumference. So that will be the statement. You understand? Okay. This one is the diamond one. Cannot see. I place again. Okay, this one. This is the one, the diamond that I mentioned. Common mistake is students say, oh, 130 divided by 2. So X is 65, which is wrong. So you should know that this one is 2X. Outside is 2X. So what you're supposed to do is take angle 360. So I will say angle reflex angle AOC. So you see AOC got two meaning. It can mean it's the 130. It also can mean it's the outside. So how do you define that it's outside? Because it's more than 180 degree, we call it reflex angle AOC. So you will take 360 degree minus 130. So you will get 230 degree. And why do you put this? It's because you're using the property angles at a point. Okay, so this is 230. So we know that angle ABC is equals to 230 divided by 2. So it's 115 degree. And reason is same thing. It's also using this property, which is called angles at the center is 2 angles at the circumference, which is at the statement here. Okay, so let's move on to the next property. I'm going to minimize. Okay, let's take a look at this question D. Okay, question D. Let's see. Okay, you spot diameter, right? There has AB. So the first thing, every time you spot diameter, the first thing is you spot the 90 degree. So I'm going to put this one is 90. So in the working, you will say angle ACB is equals to 90 degree. And why is that it's 90 degree? You need to justify and say that this is angle in a semicircle. So that's the property statement. Then you say, oh, this is 90. So now I can easily find this angle over here. I will say angle CAB will be equals to 180 degree minus 90 and minus 59 degree. Yes, semicircle. Okay, 180 minus 90 minus 59 degree. So equals to 90 minus 59, 31 degree. And again, when you write 180 minus 1, there must be a reason, right? So it's because we are using angles in a triangle. So at the side here, you put angles in a triangle. So this is 31 degree. Then angle Y, you will say, oh, so angle Y is actually equals to angle CAB, which is equals to 31 degree. And why is that so? Because it's parallel line. So you will say parallel line Z is alternate angle. So it's alternate angles, put a colon, and you have to state the parallel line. In this case, it is CD parallel with AB. And we have the answer. So this is how a lot of students may know how to find the answer, but they don't know how to put in the reason. You understand? So this is how you put in the reason. When you write something which is like, huh, out of nowhere, you say it's equals to 90. Why? Then you have to tell them it's because of this reason. And out of nowhere, you suddenly write 180 minus this one. There must be a reason. So you put it at the side here to justify it. You understand? So let's move on to the next property. Okay, this property has two names. Sometimes they call it angles in opposite segment. So why is it called angles in opposite segment? If I draw the line BD, you see, this Y is on the bottom side of the BD. Then this X is at the upper side of the BD. That's called opposite segments. That's why it's called angles in the opposite segments. You understand? So this is one name. The other name, you call it angles in silic chord. I know it's not pronounced silic. I always pronounce silic. Okay, so my students always laugh at me. Okay, so this is either you use this or you use this, is the same. So how do you spot this kind of question? First, it's a quadrilateral inside the circle, and all the 4 points must touch the circle. See, 1, 2, 3, 4. Make sure all 4 points touch the circle. You feel that it's redundant? No, it's not. Because you see, if I give you a circle, okay, let's say I put like that, then after that, this. Sometimes students spot, hey, quadrilateral, then they go and say that it's silic chord. But you see, you only have 3 points touching the circumference. This 4th point doesn't touch the circumference, it's touching the center. So this one doesn't apply to this opposite angle. I mean, opposite angles are 180 degree. You understand? So you have to always, for me, I always make it happy. If you want to use silic chord, I will mark out the 4 points, make sure all 4 touch the circumference, then I apply this property. Okay, so let's try some question. Okay, so this question, find the marked unknown angles in each of the following. Okay, let's try the A. This one a bit tougher, so I do most of it. Okay, let's take a look at 1A. See, you see, what's my habit? 1, 2, 3, 4. I mark out the 4 points. Make sure that it fulfill what I mean by the silic chord. Then I say, oh, so angle X is equals to 180 minus 107 degree. So I get 73 degree. So the reason, don't put here. The reason you should put here, because you have to explain why is it 180 minus 107. So I will say angles in silic chord. You want to say is angles in opposite segment also can. Okay, once 73 already, I put in the figure 73 degree. So angle Y, very straightforward. Angle Y is just 180 minus 73 degree, and it will be, because it's this one, right? So it's also 107 degree. And what is this? This is angles on a straight line. Okay, so this one is straightforward. Okay, now let's take a look at B. We use red color. Okay, okay, angle X, easy. See, 1, 2, 3, 4. So it means that angle X is just 180 degree minus 72, so it's 108 degree. Reason, this one, plug, copy, paste. Okay, so once I have this one, I'll put in here 108 degree. So I left with a Y, easy, because this one is a triangle. Angles in a triangle is 180. So angle Y is just 180 minus 35 minus 108. And you get the answer. And this one is angles in a triangle. Okay, these two easy. Now we look at C and D. Okay, students always ask me how to do C and D because they don't see the quadrilateral. This one, they see 2 triangles. This one, they see, wow, pentagon. Is it pentagon? No, they see hexagon. Then they don't know how to do this kind of question. So let's try our C first. Use another. So this one, first I want to do is, I'm going to draw from point E to point A, draw a line. I make it worse, right? Become 3 triangle, right? It's fine, okay? As long as I can spot quadrilateral. So what I'm going to do is, I got 103. So I'm going to use 1, 2, 3, 4. This is the first quadrilateral that I can use. And I can see this is 103. The opposite here, I can find with it. Agree or not? So in this, I can say that angle, I use another color. I will say angle CEA is equals to 180 degree minus 103 degree. So it will be 77 degree. So this one is angles in opposite segment. Okay, So I know this one is 77. Then I can find this angle over here already. This is using angle EAC is equals to 180 degree minus 77 minus 28 degree. So 180 minus 77 minus 28, I get 75 degree. This one is angles in a triangle. So this one is 75. Okay, now you see, I use another color. There is another quadrilateral. 1, 2, 3, 4. Do you see that? So this is another quadrilateral. Then I also can apply the opposite angles again. So because this is 75 degree, I will say angle X is simply 180 minus 75. So answer is 105 degree. And this is angles in opposite segment. And we are done. Okay, so this question tells me that, oh, I can have 2 quadrilateral inside the same circle. As long as I fulfill the 4 points, and then I just, okay, opposite, add up 180. Opposite, add up 180. You understand? Okay, now let's take a look at question D. Okay, no space, this one I minimize. Okay, take a snapshot because I'm going to clear and then do question D. Now, let's take a look at question D. So this is a hexagon. Then how are you going to do? Okay, try to draw a line and see how it goes. Okay, let's see. Because I got 103. If you can try, you can always try out. Let's say I'm going to join this line. Okay, I can find this already. I can find this. Yes. Okay. So this line, I draw this line. What can I get? This is the first set. You see 1, 2, 3, 4. 4, right? Quadrilateral. All 4 points touch the circumference. Then I can say, oh, so 113. So that means I can find this angle over here. So I will say angle DAP. I cannot see what my alphabet is already. It should be P. DAP is equals to 180 minus 113 degree. Okay, so you get 67 degree. And that is this part. Again, this is angles in blah, blah, blah. You all should know already, opposite segment. Okay, next, I will now find this angle over here. So I will say angle DAB is equals to 120 degree minus 67. Okay, this one 120 minus 67 is nothing to do with any property. It's just subtracting, correct? This one, you don't have to put any reason. So 120, I'm going to minus 67. You put 53 degree. And we know this is 53 degree. Then do you spot another quadrilateral? 1, 2, 3, 4. So in this case, opposite is the X mark. So I will know that angle X is equals to 180 minus 53 degree. Okay, and it will give me 127 degree. Again, this is angles in opposite segment. And we got the answer. Okay, so that's for this question 1D. Okay, tangents to a circle. So very popular property that they always like to use. Radius O to A, this is radius because it's from the center. And then they tell you it's a tangent. So it's always tangent perpendicular to the radius. So this is 90 degree. They always test one. Okay. Then after that, this one. Same thing. This one, AO and OB is radius. So the first thing you always do is, of course, you mark this out. Because you know that they are the radius, so they are actually equal. Next thing is when the two tangent line meets outside at this point T, okay, it will, this AT and this TB will be the same. And this is 90 degree and this is 90 degree. And this is, of course, the common side. So in other words, when such thing happen, actually this is called a kite. It forms a kite. Okay, and it means that triangle TAO is congruent to triangle TBO. Congruent means exactly the same. Okay, so this is one of the property that they also come out. Okay, let's base on this and do some question. Okay, in it, okay, let's see. Let's take a look at this question. A. Okay, I see the radius, I see tangent. First thing is I know, oh, I'm going to mark out this one is 90 degrees. So of course you have to explain, you have to say angle OAN is equals to 90 degrees. And why is that so? It is, for me, it's always write radius perpendicular to tangent. You want to write tangent perpendicular to radius, also the same thing. So I know this one is 90 degrees and I'm given 29 degrees here. So it means that I know angle OAB is equals to 90 minus 29, which will give me 61 degrees. So in this angle over here is 61 degrees. And this one is subtraction, so no reason. Next is in the properties of circles, right? A lot of times is you have to identify the radius. When you identify the radius, you can mark out that they are equal. This is a very critical move. Although you feel like, it's just radius, nothing to do, nothing important. But when you mark out, you can spot isosceles triangle. When you mark out isosceles triangle, a lot of times you can solve a lot of questions already. So you see, with this 61 degrees, I know this is 61. So I have to explain that angle OBA is equals to angle OAB, which is equals to 61 degrees. And why is that they are equal? It's because this is a isosceles triangle. And once I confirm two angles is 61 already, so angle X, I simply take 180 degrees minus 61 minus 61. Page it here. So it's 58 degrees. So of course, this reason is what? Angles in a triangle. And we are done. This is for question A. Okay, now let's take a look at question B. Okay. This question is, you have to draw additional line. A lot of time, the center is not joined to any point. You can always draw additional line to guide you. So I will draw the O to A, and I will also draw O to B. Okay, I join that is because that tells me that that one is a radius. I can also mark out that this is radius, they are equal. And because this is radius and this is the tangent, I also know that this is 90 degrees. Agree? So do you notice that, okay, whatever this question, this one question now also use the property that is in front that we have learned. Just now we have learned angles in opposite segment, angles of center is double the angle at the circumference, all are being used. So over here, I will say that angle BOA is equals to 2 times 40 degrees, which is equals to 80 degrees. Why? Because this is angle at center equals to 2 angles at circumference. Okay, so I know this one is 80 degrees. Then I can find this already. Because we already know it's isosceles triangle, so we will say angle OAB, OAB will be equals to 180 degrees minus 80 divided by 2, which is 50 degrees. And this is isosceles triangle. So we know this mini one is 50 degrees. So how to find angle X? Before you find angle X, you have to explain why that one is 90 degrees first. So you have to say angle OAT is equals to 90 degrees. Radius perpendicular to tangent. Then now you can happily say, oh, so angle X is actually equals to 90 minus 50 and you get 40 degrees. And you are done. So we are done with these two questions. Okay, blah, blah, blah. Okay, I spot the radius and the tangent. First thing, put 90 degrees. So we will say angle OAT equals to 90. Same thing, radius perpendicular to tangent. Okay, put 90 degree already. Then after that, what do I do? OB, it's equals to OA because they are radius. So I will say OB equals to OA equals to radius, and I shall let it be X. Since they are the same one, because they are radius, right? So I let it be X. So, and do you spot right angle triangle? And when you have right angle triangle, what do you link to? Pythagoras theorem. Because no angle is given, only sides are given, you link to Pythagoras theorem. So what you do is you will say x squared plus 5 squared equals to 3 plus x squared. Because OT is x plus 3. So then after that, I will say x squared will be equals to, this one you will have to rainbow it out. So it becomes x squared plus 6x plus 9. This one is plus 25. I bring it over, become minus 25. So it becomes x squared. Actually, this one I can bring it over. So it becomes, oh, actually this one is a yeah, don't worry. So I minus x squared minus 6x equals to 9 minus 25 minus 16. X squared minus x squared no more. I only left with minus 6x equals to minus 16. And then I get x equals to minus 16 divided by negative 6. And I get 2 2/3. So you see, when you press calculator, the calculator gives you 2.6666666. Usually you can always put it in mixed number. So it's 2 whole 2 over 3 cm. And we are done. You see, this one form equation. And what do? I spot radius. I spot radius, I let it be the unknown be x. Okay, then you form equation and you solve the unknown. This is for question 2. Okay, let's take a look at question 3a. First, I always like to do is mark out the radius. Whether you use it or not not important. Just mark out the radius, okay? Then after that, I see 65, blah, 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 blah. Then after that, we know that this is 90 degrees because it's radius and tangent. Mark it out. Okay, and oh, I can solve my angle y already. Very easy. So but of course, before that, you have to explain about this angle A, right? So you will say angle OAT equals to 90. Okay, of course, you know this reason already. Then after that, I will say angle Y will be equals to 180 degree minus 90 degree and minus 65 degree. And again, you have the answer, which is 25. So of course, this one you have to write the reason also. Now we settle angle Y already. Okay, I'm going to put it inside 25 degree. So now we have say angle X. So what is angle X? Okay, and because this is a what I call it, it's a kite. So we know that they are, you will say that angle X is just equals to 65 degree. So the reasoning is what? The reasoning is just now the property. Let me go to the name. We will say that, I'm going to paste the property here. This was the property that was shown just now. Okay, so we will say that this, you just need to state this one. So this reason you will say tangents from external points. Okay. So this, by saying tangents from external point, it will automatically means that we are forming this kite thing. You understand? So this is for part A. So let's take a look at part B. Similar. So angle Y is the whole thing. Same thing, 90 degree. Okay, I'm not going to write the full question. Just 90 degree, you'll be able to find, because you got 27, you got 90, you'll be able to find this angle. Times 2, you will get angle Y. Then again, angle X is equal to 27. So this one straight away is 27 degree. So all this, the reason is using this one. Okay. So if I'm not wrong, I'm done with. Okay, I'm done with the basic question, which is like, to you all, maybe sometimes feel that it's simple. But now you're going to combine. Okay, these are the typical kind of question that you see during the exam. Then you see, wow, so many lines, then you don't know what to do, right? So let's do step by step. Remember what I did? The first thing I need to do is spot the radius. Find the center. Oh, I can see I have the diameter AC. Okay, and they also tell me diameter AC. I can spot that this is 90 degree. Then after that, mark out the radius. OA is radius. OD is radius. OC is also radius. Important, okay, because you may use it later. Now let's see what they want. They ask to find angle ABD. Okay, ABD. So actually ABD is using the angles in opposite segment. See how I spot now? 4 points are 1, 2, 3, 4. Sometimes you may find that, how do you straight away find the 4 points so easily? There's so many points inside. You work from the angles that are given to you. Okay, I'm 39 degree. I know I can find this one, but now it's because they ask for angle ABD. So then I look at the 116. Then I can see, oh, 116 is this one. Then I look at the opposite. Then I say, oh, actually, what they're asking for is the opposite of 116, the green. So you will know that you use the green color 4 points. So you will say angle ABD, it will be equals to 180 minus 116 degree. And also one thing, students always do angle. Well, they find the answer already, they just find, but they never put the answer back into the diagram. That's very important, because you will use the front parts answer to do behind parts. So it's always important that during your exam, after you find the first part, write the answer inside the diagram. Understand? So 180 minus 116 is 64. Then I'm going to put inside here 64 degree. Okay, if no space, you can just arrow out and state that this is 64 degree. And we are done with the first part. Next, they ask for AOD. Okay. Okay, so we're done with this one. Then next is they ask for this one, AOD. And actually, if you notice, this is the common base. This is angle AOD will be equals to 2 times 64 degree, because it's angle at center equals to 2 angles at circumference. Okay, so it'll be 128 degree, and we are done. So put in the diagram, put 128 degree. Now they ask for DBC. DBC, DBC, this angle over here. So how do you find that? Let's see. Oh, okay, I can spot it already. So you see, this 128, right? I can find this angle over here. So let's find angle COD. COD will be equals to 180 minus 128 degree. And you will get 52 degree. This is because it's angles on a straight line. So put in 52 degree. Why do I need to find this? Because DOC and DBC have the same base DC. One touch the circumference of the circle, one touch the center. So I know it is also the angles at center is equals to 2 angles at the circumference. So now I will say angle DBC will be equals to 52 degree divided by 2, which is 26 degree. And reason, you should know this one, same reason over here. And we know that, let's put in, this is 26 degree. Now let's move on. Angle ODC. ODC, ODC. Over here. What if in exam I put 90 minus 64? Oh, also can. Yes, we are right. Okay. So I don't know, it's a he or she. Okay. So you're right. Okay. One thing about angles is sometimes, right, your work our steps may not be exactly the same as another person, because as long as you use the proper property, sometimes like maybe I go like I walk from A, B, C. You walk from A, B, C, but our destination is still the same because we are using different property. But he or she is not wrong, because if you have to use the 90 minus 64, you can. But before you use the 90 minus 64, you will have to explain the angle ABD. You have to explain that angle ABC, sorry, not ABD, ABC is equals to 90. Why? Because this is angle in a semicircle. Then yes, angle DBC is equals to 90 minus 64. And you're right, 26 degrees. Okay, this one subtraction, no need to give reason. So this is an alternative method. Okay, so I did this one, it's also okay. It's also can. Okay, so then lastly, the last part is they ask for O. Yes, no problem. Okay, they ask for ODC. You see, just now I mark out all the radius. You see, now it come in handy. I can spot isosceles triangle very easily. So because I already have 52 degrees and I know this ODC is an isosceles triangle. So to find angle ODC, angle ODC is very easy, which is just 180 degrees minus 52 divided by 2. So 180 minus 52, then I divide by 2, I get 64 degrees. And I will say this is isosceles triangle. Okay, and we are done with ODC. Next is, okay, my worksheet got error. This one is supposed to be OC. But don't worry, the one that we send you is already corrected. Okay, so the last part, they say ED equals to BC equals to 7. OC is 5 cm. Find the area of OBC. So let's see what they give me. ED, let's take a look. This one is 7. BC is over here. This is 7. OC is 5. This is 5. Okay, I don't know how to put. This is 5. They asked to find area of OBC. O, draw the line. B, C. So this is the area they ask you to find. Whenever they ask you to find area of triangle and it's a non-right angle triangle, right angle triangle very straightforward. It's just half times base times height. If it's a non-right angle triangle, you see whether you have any angle or not. Because you can use the formula half times A times B times sine C. So let's take a look. This triangle, I have the 5 and have 7. I'm going to just draw out the triangle so you can see. This. I got OBC. This is 5. This is 7 cm. So I have the 5 and the 7. And to use the formula, I always have to find the included angle over here. So in this question, the bad news is I don't have this included angle. But you can find. Why? Because this ABC, I can use 180 degrees. So I'm going to find angle BCO will be just equals to 180 minus 90 and minus 39. It will give me 51 degrees. So I know this is 51 degrees. Then I can easily find the area of this triangle already, which is half AB sine 51 degrees. And you get 13.600, round to 3SF, 13.6 cm squared. And we are done. Okay, you see, this is a kind of typical question that you will see during exam. So many properties used within one circle. Okay, you got to do it systematically and then always work from what is given to you, slowly work out. And very important is whatever you find must always put into the diagram. Because imagine you never put all this value into the diagram. You only see the 116 and the 39. How are you going to link to do the rest? You understand? Okay. So this is the question 1. I'm going to do one more last question. Okay, this is the last question for the night. Okay, let's take a look. Always look at the question and make sure that all the information written in the question are put into the diagram. 90% of the time they will drop, they will put in the diagram for you, but we just play safe. So they say all these are straight line, usually straight line, nothing much, very straightforward. Okay, AE is a tangent to the circle. Okay, just acknowledge that AE is a tangent. BC, the other line on the circle with center O. Okay, then they tell me 105, I can see 105, I can see 65. That means all the information are inside the diagram. Now I can proceed to do the analyzer. Spot the radius first. I'm going to spot radius. There's no diameter. So bad news, there's no diameter. You cannot have the angle in the semicircle. So I'm going to spot. There's only one pair of radius here. So mark this here. Okay. So let's work out and find BDE. BDE. So I'm supposed to find this angle over here. So you see, I'm going to work and see what can I find for my 105 and 65. Okay, I spot one. 105, I can find this angle over here. Okay, why do I need to find this? Because after that, I can see 1, 2, 3, 4. I use quadrilateral, right? So I'm going to find this angle CBE first. Angle CBE will be 180 minus 105, give me 75 degrees. So this one, of course, got reason. Angles on a straight line. And then after that, this one I'm going to put here as 75 degrees. I can find this one. So I will say angle CDE will be equals to 180 minus 75 equals to 105. Okay, this one no need to put. So this one is angles, opposite angle, opposite segment, sorry, opposite segment. Next, so the one that they asked me to find, angle BDE will be equals to 105 minus 65. So it will be 40 degrees. So this blue color angle will be 40 degrees. Okay, and that's the answer for part A. Okay, now let's take a look at part B. They asked for BCE. BCE. This is the angle they asked you to find. Okay, so let's see what can I find. Oh, okay. So you see, if I don't put a 40 degree, I won't be able to see. Do you notice that this touch the circumference and this is the center? Okay, and actually, if you notice, this and this is sharing the same BE. So for this, I will say angle BCE is equals to angle BDE, which is just equals to 40 degrees. This reason is called angles in same segment. Okay, so now this is 40 degrees. Next, they ask for angle BOE. Angle BOE. And we can see that this is double. So it's just 2 times 40, which is 80 degrees. So you should know this is angles at center equals to 2 angles at circumference. This I'm not going to write already. Okay, let's see what is the next one. BAE. They asked to find this one. So how to find the angle BAE? Let's take a look. See what I have, Okay, I'm going to put here 80 degrees. Okay, see, just now, you see, from start until now, I haven't used a tangent. So I will know that, hey, okay, maybe I will have to use the tangent kind of property, which is, like, you know, the popular radius perpendicular to the tangent. So this is 90 degrees. Okay, I can find this angle. But of course, first I have to find this angle first. So let's do the last part here. I will say OEA, angle OEA equals to 90 degrees because radius is perpendicular to tangent. Then after that, I'll have to find this angle OEB. OEB, you will take 180 degrees minus 80 divided by 2. So you get 50 degrees. This is isosceles triangle. So with this 50 degrees, you can find angle BEA. So angle BEA is just 90 minus 50, which gives me 40 degrees. So this is 40. Easily, I can use the angles in the triangle. So angle, we follow the question. They ask for BAE, we will say that it's BAE. So angle BAE is simply 180 minus 105 minus 40, and we get 35 degrees. And that's the answer. Ta-da! So we are done with this question. Okay, a lot of properties are used. Whatever I have touched on the basic properties, they're all lumped together. Okay, so that's the last question for the night.